And good morning, everybody, and thanks for joining us. Our next presentation is for BrainChip. We're joined by Sean Hehir, the CEO. I think he's going to give a presentation, and we'll follow that up with Q&A at the end. So I will turn the microphone over to Sean if you're there.
Great. Okay. Thank you, Rick. And let us move to start our presentation. So thank you, everybody, for attending. I'm very excited to be here and explain what the compute model of the future is and why it actually matters so much to customers and potentially you as investors. And it's at its simplest level, the right compute model of the future is moving much of the workload away from the data center over to the edge and attacking with a new kind of compute and AI technology called neuromorphic. And you'll hear a lot more about that through the presentation. But in the beginning, it might seem a little complex, but it's actually pretty simple. And I think once you hear about it, I think you'll agree that it makes good common sense and you'll wonder why things were not always done this way. But I always believe the right way to start any presentation is not in my words, but other organizations' words. And in this case, some of the world's leading brands. In this case, let me start with Mercedes-Benz, one of the premier auto companies in the world, very aggressive in their technology push. They've developed a new concept car called the EQXX, which is a long-range electric vehicle. And in there, they've used our technology. And this is their quote, not ours. It says neuromorphic computing, a car that thinks like you. And again, I'll talk a lot more about neuromorphic and what that means. But the real tagline here is what they discovered, that it was 5 to 10 times more power efficient than anything else they saw on the market. And that's not 5 to 10%, but 5 to 10 times. And that's a very powerful thing when power matters in cars and other things that have an electric, don't have a power cord attached to them. Renesas, one of the world's leading supplier of silicon out into the market, had some very interesting quotes. And quite frankly, one of our licensees, they have purchased a license. They are seeing a tremendous increase in demand for their products of real-time intelligence on the edge. You see keywords in there around industrial and IoT, some of the markets we are seeing this technology show up. Reality AI, a leading provider of models, has made some other comments about our technology, our ability to radically improve at the edge scale and delivery of intelligence services. And then one of my favorite, Accenture, literally the world's largest and leading consulting firm in the world. Their recently retired global CTO of all of AI said the following: neuromorphic computing has a good chance to be the leading technical approach for AI at the edge. And of course, the comment on the bottom says some of the workloads simply need to run on the edge. So I start with that so you can hear what other organizations are saying about edge computing and what they're saying about BrainChip. Now, let me talk a little bit about the company myself. So at its simplest level, we're the first company in the world to commercialize neuromorphic IP platform and a reference chip. And I'll talk about what our offering is extensively here in a moment. We've been around for a few years, several years. The first generation that was actually launched was about 3 years ago. We recently announced, and I'll talk about this, the second generation. It will be delivered in less than 30 days, and the interest is exceptionally high. We have built a world-class board and executive team. If you look at our board, we have a very senior technical fellow retired from Texas Instrument. Our chairman was the ex-president of ARM Holdings, the world's leading IP provider. I've assembled an executive team with experts in silicon and AI and IP sales. We have very large and growing ecosystem and partnerships, and I'll talk a little bit about that in a moment. And then, of course, we lean very, very hard on our patent protection. If you're in the IP business, you need to have patents. Our products at its simplest level is an IP on the top. We have some reference chips. Down the bottom, you get a sense of the partnerships that we're working with. Partnerships are everything. No technology stands alone, and you always have to work with technology above it, below it, and to the left and the right. And we're gathering and working with a set of partners that are considered like processor companies like ARM and SiFi, because people are going to build custom chips, are going to use a processor. So customers want to know that it works well, it's tested and configured. So we work with those kind of companies and platform companies and application companies, people that are porting workloads onto us. And I'll talk about how easy that is to do in a moment. So our business model for something, as we go through this and then think about this, the right way to look at us is an upfront cash payment to acquire single or multi-use product IP. If someone's going to build one chip or they're going to build multiple chips, they buy a license. Those licenses are typically 7 digits and to start. And then in the middle box, there's obviously some engineering support that we charge for. And then, of course, once the chips themselves are created, royalties start to come in and roll out, and we collect a percentage of the ASP, and we get royalties. And of course, those royalties are virtually 100% margin at some point. So you can think about this when you build this to scale. You can get very high margin business, and you'll see right now. Obviously, we're in the early days, and we're not there. But when we go up to volumes in our projections, you'll be a very high margin business with them. So let's talk about some of the problems that our technology can address and why it matters. And so you can get a sense of the opportunity, which will come up next. The cost of training a single high-end model, the way AI works is you create models, you train them, you deploy them and infer. The cost of training models is exceptionally high. But if you can modify the models and add classes and objects, if you will, on the fly, on the device, you avoid a lot of training costs. Our technology allows you to do that. If you think about the applicability of technology and what we can do with it, 50 billion in loss annual for manufacturing downtime. One of the primary use cases for edge computing is around manufacturing and IoT. If you can get a sense of a vibration or a noise signature and take action on it locally, you're going to have tremendous improvements in your downtime in any factory or any other kind of manufacturing facility. Cards are now just rolling computers with lots and lots of data. Old kind of architectures had all that data going to a central ECU, if you will. Modern companies and really groundbreaking companies are developing what they call zonal kind of computing and trying to distribute that work out through the car itself and avoid all the data movement for failures and redundancies. So if you have edge-based technology like us, and we're seeing a lot of interest from auto companies, the ability to do that in various zones makes a big, big difference. And of course, at a power efficiency. And then of course, the applicability to change lives with healthcare, because anything that is without a power cord can use AI. And so we're seeing a lot of interest in the healthcare vertical as well. But let's talk about opportunity. You know, most of you, or if you're even a casual observer of artificial intelligence, are fully aware of these things like ChatGPT and others that are all in these data centers. And the data centers, there's 10,000 of them around the world. But to give you a sense of how big the edge opportunity can be, there is many, many more edge-based devices. McKinsey is saying up to $70 billion worth of edge devices will need AI in just a few years. If you look at the AIoT revenue, it's a massive opportunity, all responding to those key challenges that you see over there on the bottom right. And my last comment a little about the market before I start to talk a little bit more about our offering and what it does, and then the business itself, is Gartner, which is obviously one of the world's leading analyst firms that enterprises look at for use and try and decide their technology directions. This is something they just put out a couple of months ago. And if you look at that orange circle, the Edge AI, which is right in the heart of driving the productivity revolution in this country and other countries, they believe strongly this is going to be the productivity driver for most of industries. Another interesting observation is critical enablers that popped out here too, where they have neuromorphic computing. And I'm going to describe that coming up here in a moment, but the ability to do things differently, get greater output with less input. So let's describe a little bit about the edge before we go into the company. The cloud is where the majority of AI is computation is done today. But wherever there's challenges to scaling a purely cloud-based model because of the exponential growth in demands and power, storage, network, and quite frankly, concerns on privacy and security from all the bandwidth and data moving back and forth. As AI applications are growing very, very quickly and growing in complexity in areas such as autonomous driving, industrial, factory management, they can't afford the latency of sending this back, and they need real-time responses and real-time experiences and you can't do that with all the stuff in the cloud. So at the edge, you see a wide spectrum of devices that make up the edge, from the network edge, which could almost be like little network hubs or servers outside the cloud, down to the far edge, which is really just a sensor. There's lots and lots of opportunities on where that can be addressed. And you can see the kind of needs about that we address, the ability to do it on device and power efficient, low latency, et cetera. That's the use case where our technology fits, not the data center. I'm often asked, actually, could you go to the data center? And the answer is yes. There's nothing with our offering says it could not. But we see that as a served market with well-entrenched competitors. The edge market, on the other hand, is fragmented, developing, larger, well capitalized names that you're familiar with in the silicon business are just barely touching parts of it and not going very deep. So let's talk a little bit about neuromorphic, because it's really the driver of our technology. And I'll describe later on when I get to the competitive section what few players are available in that market for neuromorphic computing. But at its simplest level, it's modeled like the human brain. The brain is the most efficient computational engine there is. And what we only process things that are different and change. And what I like to say is use as an example. If we were all physically in a room together and we had a break or coffee break, and I was walking around and meeting people, shaking hands, what I would look at, like most human beings, is the differences. I'm not trying to memorize the facial structure, because most of us have 2 eyes, a nose, a mouth, 2 ears. But what I look for is the hair color. Do they wear glasses? Do they have a beard? That's how the brain works. Just look for the difference. And that's quite frankly what neuromorphic computing is. Just taking advantage of events and only the changes. And when you think about it, that allows you to get extreme efficiency, because you're not wasting all the cycle trying to relearn everything. And that's why you can get greater performance for less input, and you can get the incredible power savings that I described earlier. Another unique element of it is what we said is this on-chip ability to learn local, which is very unique. The ability to get and look and add new objects. And the one we talk about a lot would be if you had a family, let's say of 5 people, and you had a doorbell, and you walk up and you look and you're in and you're authorized to come in. If you wanted to add a new person, somebody you just married or something like that, you just take a picture and they're in. That sounds simple, but without edge computing, you would have to go back to the cloud, retrain, redeploy, a lot of costs and a lot of delay. So neuromorphic computing, so it's a very unique way to go about it. And when I talk about it, we are the only commercially available neuromorphic processing company in the world that's out there today. Let's talk a little bit further about it. Why does that matter? When you hear, and I'll talk about some other companies that are researching it, we are fully digital. Why does that matter versus analog? Most people think analog. When you think about analog, it's cumbersome, it's slow. We're fully digital. And what that means, if you're an IP provider, you can take that offering and move it to any kind of fab in the world and deploy it. Our first chip was done on TSMC as an example. Our second chip, which we're just getting back right now, came out of Global Foundries to illustrate the portability of this technology, but it can certainly go to any fab. Very, very important. The ability to do complex models in the hardware. Why does that matter? Well, a lot of stuff, when people are doing edge computing today, they're still reliant on the CPU. We can actually offload the CPU totally and do all the model processing in the hardware itself. That allows you, when you're building a custom chip, to get a much smaller processor or use that processor for application load. So you've got a highly optimized neural processing unit. I mentioned the on-chip learning and customization, very unique to do it on the fly. And then something that's really, really important is this ability to deploy models for today and tomorrow. So when I say neuromorphic, I don't want to scare people, say, oh, it's only what we call SNN, spiking neural networks, which is really a neuromorphic network. We run them and we run them exceptionally well. You can develop them exceptionally well on using our offering, but you also can move today's models. Most of the world runs on something called convolutional neural networks today. We have a utility called MetaTF. At its simplest level, you can run MetaTF and deploy your existing model onto our hardware and come up with the same kind of power savings. Why does that matter? When you're a breakthrough technology company, and this applies to AI or anything else, and you really try to get the groundbreaking performance that we're providing, you also have to be mainstream enough in your approach so people don't say it's too hard to adopt. It's too different. I've got my investment in models. We have a way to protect it. If you've got models running in some old architecture, you use MetaTF, you port them onto us, very easy. That's a critical part of our strategy, the ease of portability. Let's talk a little bit about our protection and our portfolio. So if you're an IP provider, it's critical that you have a very strong patent portfolio. And you can see the number of patents that we've been granted and the ones that are pending. And if you look at the titles across the top, it's a good smattering of the full value chain of artificial intelligence. You've got to protect all the way through the training, through the inference, on the synthesis, and every part of it. And a company now that we are slightly less than 100 people and growing, we have 2 full-time attorneys working on patents, and obviously use a lot of external resources. That patent portfolio will continue to grow and will be a cornerstone of the value of the company. I want to talk about our innovation model, because hopefully you're picking up a really important theme here, which is if you're a company like us, we're all about driving innovation, because innovation is everything if you're trying to break through these paradigms and create new things like a neuromorphic engine. So we're looking on the left side, a classic kind of product management function that looks at all the external things from analysts, market requirements. We talk to our customers and our prospects. We pay close attention to the academic trends. But we think one of the secret sauces of this entire company is this right-hand side. We have a research institute where we've got several scientists in that research, and they are free to dream. And they're the ones who are dreaming of the next generation and the generation after that. And I call our North Star. So they're working on some very groundbreaking things at all the time, just like a university or a government. They get some light touch direction from our product management to make sure it has some direction aligned with the industry, but they're really big dreamers. When they come up with some concepts, it then goes over to our applied research group, which is critical. That applied research group, again, PhDs, neuroscientists, engineers, will work closely with our original research group and decide, can this actually make it into a product? Is these concepts even achievable? If the answer is yes, then we go to an engineering roadmap and put it into our products. Now, I think what's really important to understand is, so that's the innovation engine. I recently told our shareholders at our annual shareholder meeting, it took 3 years from version 1 to get to version 2. I've laid a goal out for this company that we will get every new year, we will have a new version in 12 to 18 months at the latest. So while we're finishing version 2 right now, and we're finishing it up at the end of this month, early September, we were already planning for version 3. That is what's going to be required, and we demand of our company to can keep our lead. We've got a tremendous lead on the market, but we're not going to back off. We're going to accelerate it. So we're already planning our version 3 to go forward with. Let me talk just a moment at a very high level. I know this is not a technology conference, but an investor conference, but I want to talk just a moment about our second generation, because it's a cornerstone and what that could mean to you as investors. Let me start with an investor comment. The interest level and the new things that we've got in generation 2 of our platform is exceptionally high. And what I say a lot, we are in more prospect conversations, in deeper prospect conversations, and in more industries than we ever were on our version 1. So tremendous interest. And why is that? We've certainly made some changes in our core offering. where we included things around different, we should only support 4-bit, but now we do 8-bit, 2 and 1. We do skip connections, things like that. But what's really getting the people and our prospects' attention is some of the very interesting breakthroughs around things with the ability to do vision transformers at the edge, which is really important, which is a type of model. And then something what we have a very proprietary and breakthrough called TENS, which is spatial temporal support models. And that allows you to get unbelievable kind of performance around things about up to 500 times more efficient and do things with much less parameters, less compute, less complexity, all with the same kind of accuracy required in artificial intelligence. When you look at that, the use cases is pretty powerful, because when you can do less parameters, you can build things in smaller pieces of silicon. So we've got tremendous interest from the hearables market right now, because if you're going to build hearing aids or something or noise cancellation, strong interest from several companies in that market. Healthcare devices, because now you can do things in very small pieces of silicon. Out of our platform, and I won't go through this in great detail, but I just want to kind of illustrate our strategy for you as investors. Out of that platform, we're productizing 3 major offerings, and we call them E, S, and P. And then and you can get a sense of where they fit. On the E level, it's really geared at where MCU work is done today, where some work is there, but it's not very efficient at all. And quite frankly, they quickly run out of work, the ability to handle the work as models are getting more complex. The interest coming from people with MCU solutions now, it's like we need something that can handle the more complex models and use cases for there. On the S, which we have a lot of strong interest, this is where high-end MCUs are coming. Usually it's some homegrown solutions that people have in-house. And now we're seeing interest in those kind of companies. They're saying, hey, we want best in class, we need more performance, we need lower power. And so that's where that's coming from. And on the performance edge, it's very interesting, because here, now you're in something that's, when I started that earlier, that presentation about server and network, you're now in that circuit, that server or hub kind of thing. This is where now we're rubbing up against NVIDIA Jetson and things like that. And the value proposition to customers there is really simple. Those solutions are very expensive. If you're building your own custom piece of silicon, you're actually going to get a cost savings that's orders of magnitude to it. By the way, I'm often asked about that too, about people building silicon versus buying pieces of silicon. World-class companies today are vertically integrated in every part of the spectrum, meaning they're building software stacks and building hardware stacks. And that includes to the silicon level. The pace of change and people building custom silicon, and that includes AI custom silicon, is accelerating. The idea of one size fits all kind of general purpose CPU and GPUs is over. People want custom silicon highly optimized for the use case that they're working on. Let's talk a little bit about the competitive market and how it works. I've got a couple of slides here that I think you might find interesting. That orange box that you're looking at right there that describes the edge is real. That is really, similar to the one we had earlier up today. But I want to look at, you can see where we start with Akida, which is our brand name for our offering, down the bottom. We can cover the full spectrum of all the way from the near edge in the literally part of a sensor up through the server edge with that. So we have a very broad, flexible, scalable offering in there. If you look at some of the people that are close on the far left, they're chip companies in very low functionality and, quite frankly, no flexibility in its use cases. You saw earlier, we can handle all 5 of the human senses in a variety of use cases. The people on the really far left are very narrow in their offering. The next line up, a lot of these are IP providers. They're one chip company in there, and in there, they don't cover the full spectrum. And quite frankly, their functionality and their performance footprint is not as strong as ours. You go up to the more server side, and this is where you're going to run into as well entrenched competitors I mentioned earlier in there. And again, if you look at where we are, it's a cost thing at that point. With Akida, you're going to be able to do this if you build a custom chip, because all of these are hardware providers in that line. And you're going to build a custom chip. You're going to get a highly optimized performance, and you're getting it at a lower cost profile. And then, of course, the next line up, you can look at some of the offerings from ARM and Google, and to their, again, they don't address the full spectrum of where we are, and don't have the kind of cost footprint for licenses and that we do. Let's talk specifically about neuromorphic just for a moment so you get a little sense. I mentioned we're the only commercially available offering in the market, which is true, but IBM and Intel are working on some offerings, and these are research offerings. They're no plan. We have no announced plans to commercialize them at this point. They're trying to understand and how it can go, but you can see some of the difference. The others are just kind of classic ones below it, and I'm just going to walk you through the chart. If you're neuromorphic, you're going to get the tremendous power savings in the top 3 lines. But the others, obviously, they're much higher power use. And of course, when you're in the edge, power matters a lot. When you look at the ability to do the on-chip learning locally, it's only us. The others can't do it unless you do it on Intel Lohi, which is a very complex programmable one. And probably the most important one, I think, on here is if you're really looking for neuromorphic, the ability to do it with industry standard ML workflow and frameworks is critical. Specifically, most of today's engineers work on something called TensorFlow Keras or PyTorch. We support both. If you know those, you can work on BrainChip Akida. If you're trying to work on True North or Lohi, you're going to have to learn a whole new framework. And now that, how you imagine, now you got to train your engineers and scientists. So we get the breakthrough of our performance, but mainstream tools. And then, of course, the ability to do the workload into itself. Let me bring us close to, we've got 1 or 2 more slides, and then we look forward to taking some questions. So at the end, the way we walk our customers through this is you have the ability to evaluate. You can go to MetaTF online. You can put your models, simulate your performance. We have a model zoo. People can look models and download and look at them. They can develop models in Edge Impulse, which is a leading kind of GUI platform that we work closely with, or they can modify their models using either one of those. We do make evaluation systems out there. It's not a big commercial model for us. We do sell them for a moderate price or boards. People then take it, look, try their models, and then they go to the next step, which is, of course, buy a license. So the way to think about us at its simplest level is just what I said. We have a very strong team here at this company. We've got adequate funding and room to grow. We've got a very strong investor base and support in Australia and growing in other parts of the world. We've got a massive advantage in neuromorphic AI, which is a fast growing market, as you saw from some of the data. Our new offering launched and available coming up in less than a month has tremendous prospect interest. The forecast is going quickly in this market. We've got many EAPs, some names you can see, early access people. We have a growing partnership program, which is critical for any technology to have. And we've announced some commercially licenses for Renaissance and Megachips. So the way to look at us is a clear business model with IP licensing and look at the high margin royalty streams. And with that, I will take any questions if there are any.
No, excuse me. Thanks, Sean. Maybe if I could kick off with a question or two. I guess the first one I had is MetaTF. I mean, you mentioned it trains and tests, neural networks, and I'm curious, are you seeing demand for training at the edge? And maybe a second part of that question is as you guys sort of start to proliferate out at the edge, I mean, is it possible that you could see basically customer demand pull you back toward the core, back into the data center over time? I mean, so is that another avenue for growth longer term for you guys?
Yeah, we could. That's why I said we definitely could. We technically it's an IP, right? And we modeled up to several hundred node configurations, so we know it can do it. But we purposely chose the edge because it's so underserved and because of neuromorphic nature. If you go into the data center, you're going to have a power supply, obviously, right? But we do see the day, again, I don't have it as part of our core strategy where that could happen, because even data centers with power sources are under a lot of stress. You probably have seen this stat which says, or this quote, after cryptocurrency in data centers, AI is the next biggest consumer of electricity. That's not sustainable. So two things are going to happen. Workloads are going to have to go to the edge on technologies like us, or more efficient technologies got to go in the data center, probably a combination of both. And yeah, we could get pulled there, but we're a smaller company and we're focused on where we're focused right now. But no, I would never say never, and could go there for sure at some point in time. Around the comment about edge, it's really the ability to do the inference at the edge. META-TF just allows the ease of portability and model development to do things. So it's not a lot of training yet to the edge. It's really the inference at the edge. But the ability to modify and add things in that one-shot learning, that's what you see, not the training element itself, the demand.
So not to put words in your mouth, it sounds like having like a full software hardware platform like you guys describe is just as important at the edge as it is, when you think about CUDA and what kind of NVIDIA is established in the core. I mean, it sounds like they're pretty comparable. If I don't be not putting words in your mouth.
No, that's a great question, and I really like that one, because it is true. It's always the hardware and the software, and we're always looking at what's out there in the market and how to make sure we do that. And we take tremendous pride in the software stack and the ease. I do podcasts here, or the company does, and I did a few, and I did one recently with Jeffrey Moore, if you know him, a very famous business author. And we had this great conversation about breakthrough technologies like us. The ability to make it easy for people to do and deploy is a critical thing, because even if you're the best technology and it's hard, you're not going to win. So yes, the software stack is critical. And that's why I mentioned things about the ability to take models from today and move it on, the ability to develop models simply, the ability to have your engineers still remain trained on industry frameworks and not have to retrain them on ours. These were conscious business decisions to make it easy for people to choose us.
Got it. Nope, that's really clear. And I saw that you're partnered with ARM and Sci5, RISC-V, obviously. I mean, are your chips, based on any particular architecture? Are you relatively agnostic? I know you talked about licensing, so I don't know if you could just give a little bit of color there.
Yeah, we are completely agnostic on that. The reason we have those partnerships is if people go out and develop their own chips, they're probably going to work with one of those two processors. And so they ask us, do we work well? So yes, we do. And we have partnerships with them where we obviously work with both of them in-house to prove it out, test, document, configure. If you even look on our website, we do some joint webinars and things like that to talk about our value proposition. But we're completely agnostic because we want that to be a customer choice.
Got it. And on that, roughly on that theme, I mean, you mentioned that you taped out with GlobalFoundries. You've obviously already taped out long ago with TSM. But I also read that you had partnered with Intel Foundry Services as well. So I didn't know if you could talk a little bit about your manufacturing strategy, primary partners, and part of your answer, Sean, I'm curious, are you seeing speaking to customer pull, are you seeing customers ask for, onshore silicon or domestic silicon supply, in this weird environment we're in with all the geopolitical stuff?
Not yet. I do anticipate the day. In fact, there was some interesting European news today that came out. I think it was Infineon, NXP, others, about creating a new manufacturing site over there. But we're not seeing that made in America pull right here yet, but I'm sure the day will come. But around our strategy, working with all these providers, is just, again, to prove to our customers and prospects the portability aspects. And of course, Intel Foundry, if people aren't familiar, is an independent foundry service. And so, yes, we're on there. We're in their platform. They look at us. They say, yeah, we support it. We're on their page. They've looked at our technology. It'll work well. So if a customer wants to take a chip out in Intel Foundry, they can have confidence that we're there. And we will add more foundry partners too. That's not the end of it.
Got it. Pivoting to auto, just a couple of your markets, that seems like one of the bigger opportunities for you guys. I don't know if you could talk about the content opportunity for BrainChip and maybe describe how that shifts as we sort of move up from, level 3 to level 4, level 5, you know what I mean? Like sort of how that progresses for you guys.
It's a big opportunity for us in a lot of ways. When you think about the auto business, it's a lot of places. Certainly we have interest from auto companies in the in-cabin experience for sure. The autonomous driving push is obviously very strong across the industry, and everybody's looking for breakthrough ways. But they have to make sure they do it obviously power efficient, but it has to demand absolute accuracy. Well, the only way to do that is obviously run more and more models many times and balance it back and forth to make sure you don't have a mistake. So the efficiency part of our offering allows you to maybe run multiple models, different models, to kind of check each other. And that's where we think we see the biggest interest, because if you have a big monolithic offering and it's power sensitive, you can't afford to run it. With ours, the interest is because we don't suck a lot of power, and the ability to do it, you can fit all of these multiple independent instances, if you will, in an auto. That's really the play.
Got it. And do you care? I mean, you mentioned zonal. Do you care if it's zonal or domain? I mean, are you going to play regardless?
We're going to play regardless, but we actually believe very strong in the zonal strategy.
And have you ever level set folks on sort of where you are with sort of the number of engagements? And I'm also curious always, on go to market, especially company your size. I mean, in terms of, kind of maybe a little more focus with your spend and where you're going to attack on the customer side. Do you go right to the OEM? Do you have to spread your bets with the OEMs and the tier ones, or sort of how do you go about that?
Yeah, that we could take a whole hour to talk about that, but I'll try to do it in a minute or two, right? So if you look, we sell to many kind of class of customers. So yes, we sell to the brands and the OEMs themselves to create the pull, and then of course we sell to silicon providers and others in between. So it's like we call it a push-pull model, right? So I mentioned a couple of licensees. Obviously, we sold to them and they create product and push that out to market. The OEMs are going to build their own custom chips. And so we sell to all of them. It's interesting you kind of started the first part of that question. I've been here now 18 months, and one of the biggest things we try to do is focus on expanding that go-to-market offering. When I joined, we were only focused in the US. We now have sales footprint in Japan, Korea, Israel, Europe, much broader in the US. We were just not paying attention to the rest of the world. And hence, you said level set on the opportunities. We have a much more balanced set of, really deep engagements all around the world and across all those classes, OEMs and silicon providers.
Got it. Well, Sean, this has really been great. I really appreciate you taking the time to visit with us today and present, and it was great seeing you. So thanks again for the talk or the presentation.
Thank you so much. I really enjoyed it, Rick. Good to see you.
All right. Likewise. Take care.
Bye. Bye.
Bye.